Hey everyone, welcome to Compound Inequalities. Let's get started. So what are compound inequalities? Compound inequalities are two inequalities that are joined together with the words and or. So an example would be something like x is greater than 6 and x is greater than 10. And an or example would be like x is less than negative 4 or x is bigger than 100, okay? And yes, there's gonna be more stuff on them and we're gonna talk about them a lot more, but that's kind of a visual for you. So let's talk about the first type of compound inequalities. Let's talk about the or problems. So here's an example of an or compound inequality. X is less than or equal to negative 2 or x is bigger than 3. Or inequalities have a tendency to graph apart. And let me show you what that means. So x is less than or equal to negative 2. So instead of closed circles and open circles, we're going to use our brackets and parentheses. So since this is a closed circle, we're going to put a bracket on negative 2. And x is less than or equal to negative 2, so that's going this way. Or x is larger, that's an open circle, or x is larger than 3. So here's 3, put a parentheses, and x is larger than 3, so it goes this way. So notice how whatever x is, it's either smaller than or equal to negative 2, or it's bigger than 3. It can't be both. You can't be both smaller than negative 2 and bigger than 3 at the same time. That's why we didn't use the word and for this scenario. Because you can't be here and here. You can't be in this part of the number line and this part of the number line at the same time. So that's what makes this called an or problem, also because it says or. And like I said, most or all inequalities have a tendency to graph apart because you're either in this area or you're in this area. So how do we write that in interval notation? Well, x can be any number from, let's start over here, from negative infinity to negative 2, close bracket, union, open parentheses, from 4 to positive infinity. So we put this solution set in interval notation and put a union to show that there's a gap between them, but we're uniting them as one answer. So instead of two separate solution sets, it's one solution set where x is either from negative infinity to negative 2 or from 4 to positive infinity. Let's try it in a problem. So here's an or inequality that we have to solve. You have x minus 4 is less than negative 7 or 2x is greater than or equal to 12. So you solve each inequality separately. So we add 4 to both sides for this first one and you get x is less than negative 3. Okay, that one's done. And then we do the other one. So we divide by 2 to solve the other one. And x is greater than or equal to 6. So my solution written down is x is less than negative 3 or x is greater than or equal to 6. So now we come and graph it to write our answer in interval notation. So x is less than negative 3, that's a parentheses on negative 3, and x is smaller than negative 3, so that's these numbers. And x is greater than or equal to 6, that's a bracket on 6, and x is bigger than 6, that's those numbers. This was an or problem, so it's not a surprise that we have a gap in the middle. X is either smaller than negative 3 or x is bigger than or equal to 6. So we express that in interval notation, starting from the left, reading it from the left to the right. So the smallest number over here is negative infinity. That's the smallest x. That's going to go all the way to negative 3, parentheses. For my gap, I put a union. And then we're going to bracket from, that is 6 back there, 6 all the way to positive infinity. So we're reading this graph from left to right and scribing it down in interval notation, where the U represents the gap from this group to this group. All right, let's try another one. So in number 2, we've got negative 3x is less than or equal to negative 9, or 5 plus x is smaller than 6. So this is an OR, so we should be expecting the graphs to be apart. Let's solve each inequality. So divide by -3, divide by -3. I just divided both sides by a negative, so x is greater than or equal to +3. We had to flip the inequality. Again, because I divided by a negative on both sides, I had to reverse the inequality sign. Here I've got 5 plus x is smaller than 6. So I'm going to subtract 5 to zero it out on both sides, and x is smaller than 1. So my answer is x is greater than or equal to 3, or x is smaller than 1. Now we're going to graph it and express our solution in interval notation. So x is bigger than or equal to 3. That's a bracket on 3, pointing x to the right, because it's bigger than or equal to 3. And x is smaller than 1. So that's a parentheses on 1 and pointing to the left because x is smaller than 1. Now to express this in interval notation, read the number line, the solution drawn from left to right. So from -infinity to 1, parentheses, union, bracket, from 3 to +infinity. So you're, again, to go for interval notation, you're reading the number line, your graph, you're reading it from left to right. And the gap is represented by a union, a U sign. Go ahead and try number 3 and answer the questions along the way. Okay, so now that you have tried number 3, here's the solution to number 3, solved out, graphed out, and in interval notation. So now that we've taken a look briefly at type 1 OR inequalities, it's time to take a look at type 2, the AND inequalities. AND inequalities have a tendency to graph together or connected. So just like our OR inequalities, or as our OR inequalities graphed apart, our AND inequalities tend to graph together or connected, like I said. So here's an example. We have an AND inequality here. X is greater than or equal to -6 and smaller than or equal to 1. Now what I'm going to do is I'm going to graph each one separately and show you the AND. So x is greater than or equal to -6. That's a bracket on -6 and going that way. But x is also, it's also smaller than or equal to 1. So here's 1. Oh, and it's bracket. Yeah, here's 1 and it's going this way. So it's not OR, it's AND, which means x is bigger than -6 and smaller than 1. So which sets of numbers are bigger than -6 and smaller than 1? That's going to be this set right here where they overlap. So my graph will look like bigger than -6. Let me get my pen. Bigger than -6 and smaller than 1. And it's the numbers between -6 and 1. So the only numbers that are bigger than -6 and smaller than 1 are the numbers that are between -6 and 1. So like we said, AND inequalities have a tendency to graph together. What I showed you is I showed you each one separately, kind of over it, so I wouldn't draw on my number line. I showed each one separately, and then I needed to AND them. I needed to find the intersection. I needed to say, where is x bigger than -6 and smaller than 1? That is in between -6 and 1. And since both are or equal to, we have brackets on either end. So how does that look like in interval notation? Well, read the number line from left to right. -6 is our smallest x value, and 1 is our largest x value. There's no infinity, because if x needs to be bigger than -6 and smaller than 1, it's going to be any number in between here. It'll never go off forever in either direction. So because the solutions to an AND inequality fall between two endpoints, they're frequently written in what's called a more condensed form. So for example, let's say the one we just talked about, x is greater than or equal to -6 and x is smaller than or equal to 1. Well, we just talked about, this was basically saying that x had to be between -6 and 1. So that whole concept of between That's what we're going to express in this, what I call double inequality, where we write -6 is smaller than or equal to x, who's smaller than or equal to 1. X is in between -6 and 1. And we can take a look and see, if we cover that up, we see the inequality x is larger than or equal to -6, just in the reverse order. So if x is bigger than -6, the -6 is smaller than x. -6 is smaller than x. And if I move the box, you'll see this inequality. X is smaller than or equal to 1, x is smaller than or equal to 1. So we basically turned this one around, still keeping the -6 obviously in front of the small part of the inequality sign and the x in front of the big mouth of the inequality sign. Turned this around and squished them together. And basically we're showing that x is a number in between -6 and 1. So let's take a look at this example. It's not an or, because it literally doesn't say or in it, okay? Or problems have to say or in it. Or compound inequalities have to say or in it, because you're either here or there. And problems will either say and, or they'll look like these in between double inequalities, where we're saying that x plus 4 is in between 2 and 9. X plus 4 is in between 2 and 9, hence the and. So here's how you take care of one of these inequalities. Since the variable's in the middle, what we're going to be doing is we can rewrite it as two inequalities that say 2 is less than or equal to x plus 4 and x plus 4 is less than 9. Notice how all I did was I kind of mentally blocked this off and wrote this inequality right here. And then I blocked this off and wrote this inequality right here and wrote the word and in it. Since the inequality, the x plus 4, the inequality is kind of between or embedded between 2 and 9, this is, like I said, an and inequality. So x plus 4 is between 2 and 9. 2 is smaller than or equal to x plus 4, and x plus 4 is smaller than 9. So we wrote it into two inequalities separated by and. Let's solve each one. So -4, -4, and we get that -2 is less than or equal to x, or we could say x is greater than or equal to -2. So these mean the same thing. And over here, -4, -4, x is smaller than 5. So let's put that over here. So we have x is greater than or equal to -2, and x is smaller than 5. So when x plus 4 is between 2 and 9, x must be bigger than or equal to -2 and smaller than 5. So let's take it over. Let's take it over to our number line. And x is greater than or equal to -2. So here's -2 bracket going this way, but smaller than 5. So there's 5 going this way. So x is between -2 and 5, between -2 and 5. Now I want to share something about this question. Oh, let's do the interval notation first. It's between -2 and 5. So the smallest value, reading it from left to right, smallest value is -2. Keep on cruising, stops right here at 5 with a parenthesis. So there's the interval notation. So I want to share something about this problem. Let's look at it one more time. I think that's what it was. No, 2 is less than or equal to x plus 4 is less than 9. Sorry about that. Okay, so you know how I set it up? Do you know how I set it up into two inequalities with and, right? I said 2 is smaller than or equal to x plus 4, and x plus 4 is smaller than 9. Well, you can also subtract 4 right here without setting it up. Just know that you have to subtract 4 to both parts of the inequality. And you get -2 is less than or equal to x, who's less than 5, which is basically what we just said. that x is between -2 and 5. X is between -2 and 5. So option 1 is you could set it up into two inequalities separated by and, or by doing the covering up thing, this one and this one. Or you can recognize since this is an and problem because it's in between 2 and 9, when you subtract that 4, you need to subtract it from each of the inequalities because there are two of them, like we did over here. And here's your final answer of x is between -2 and 5. So I'm going to do number 7, and we're going to do it by not separating it into two inequalities. So I see that this is an and problem because 7x minus 13 is between -27 and 8. So to get x by itself, we have to add 13 to both inequalities. That zeroes out from the center, and I have 7x is between -14 and 21. Okay, and then I need to divide by 7 on both inequalities. So I have x is between -2 and 3. So there is my inequality answer. X is between -2 and 3, or -2 is smaller than x, and x is smaller than 3. So x is in the middle. Not in the middle, but x is any value, not in the middle. X is any number between -2 and 3. But it can't be -2 because that's not or equal to, and it can't be 3. Okay, so we graph that with parentheses. Okay, I put 1 on -2 and 1 at 3. And -2 is smaller than x, so x is over here, bigger than -2. And x is smaller than 3, so over here, smaller than 3. So in between, oh, let me get my pen, in between. And in interval notation, that would be from -2 to 3. So hopefully that helps you understand a little more about compound inequalities, both or problems and problems.